Okay, this video is about the step pattern and how we use that to graph a quadratic relation. So let's take a look at this given quadratic relation. Y is equal to x minus 2 squared minus 3. Now, being the super sleuth that you are, you would recognize that this is written in vertex form, which means that we can read the vertex right off of the equation. And remember, the vertex comes from this value here and this value here. So, and the x value is the opposite of what it looks like in the bracket. So the vertex of this quadratic relation is going to be at 2, the opposite of that one, but then this one we take at face value and negative 3. Okay, so the vertex is going to be our starting point. So let's go to 2, negative 3, and put that point there. That is going to be our vertex, and that's our starting point. But where do we go from there? Well, some other information I can read off of the equation is that because my value in the very front, which we call our a value, because my value is positive, that is, it's greater than 0, then I know that my function is going to open up. Okay? The other thing I recognize is that my a value is 1. There's that imaginary 1 in there that we don't have to write. So if you have an a value of 1, which is our basic step pattern, so the a value is equal to 1, then from the vertex point, what the rule is, it says I'm going to go over 1 and then I'm going to go up 1 to get to my next points. And we do that on both sides. So let's do that. Let's go over 1 space, up 1 space, and that's going to give us our next points. And it's going to mirror it on the other side. Then, from that new point, I'm going to go over 1 more, and I'm going to go up 3. So I'm going to go over 1 more and up 3 points. 1, 2, 3. So here's going to be my next point up there, and it mirrors on the other side. Over 1, up 1, 2, 3. And then, from that new point, I'm going to go over 1, up 5. Over 1, up 1, 2, 3, 4, 5. So it's going to take us a little bit off our grid here. And over 1, up 1, 2, 3, 4, 5. They're going to mirror because they're symmetrical. Okay? And then we're going to connect the points. And notice that my function just keeps getting wider and wider and wider and wider. And I'm going to indicate it keeps going with an arrow at the end. Wider and wider and wider and wider. Okay. So there we go. And that's how I would graph this function. Let's take a look at what happens when the a value is not 1. Okay, if the a value does not equal 1, then the pattern, instead of being over 1, up 1, is going to be over 1, up 1 times whatever the a value is. And then it's going to be over 1, up 3 times whatever the a value is. And over 1, up 5 times whatever the a value is. So let's give us an example here. Let's say we're talking about the function y is equal to, let's do this, negative 2 times x plus 3, and let's go plus 4. Okay, so here's our new function. Oops, and I need a little squared there to make sure that it's quadratic. So again, being super sleuths, we recognize that this again is written in vertex form, which means that I can read my vertex right off of the function. So my vertex for this function is going to be at negative 3, positive 4. So that's my starting point. So let's go find out where that is. And I'm going to graph in a different color so we can tell them apart. Let's go purple. That's always nice. So let's go up to negative 3, 4. So negative 3 on the x, positive 4 on the y, 1, 2, 3, 4. So we're going to be starting here. Okay, so that's my new function. Now, let's go back to what the function was. And it is negative 2 is my a value. There's my a value right there. My a value equals negative 2. So that's going to tell us two things. Number one, the negative sign is going to tell us that the relation opens down. And then the second thing is the 2 value means that all my A values, all my step patterns are going to be multiplied by 2. So my step pattern is going to look like this. Instead of over 1 up 1, it's going to be over 1 up 1 times 2, which is 2. And then instead of over 1 up 3, it's going to be over up 3 times 2, which is 6. And then over 1 up 5 times 2, which is 10. But, so 2, 6, 10, those are going to be my next points, but because it's negative, we have to go in the negative direction. So I'm going to be going over 1, down 2 to get to my next point. Over 1, down 6. 1, 2, 3, 4, 5, 6 to get to my next point. And that's going to repeat on the other side. Over 1, down 2, and over 1, down 6. And so with an A value of 2, this function is a bit skinnier than a function with an A value of 1. It doesn't open quite as wide. And that's how the step pattern works. There's the basic step pattern of 1, 3, 5, 7. And then all the other step patterns are based on this, but we multiply it by whatever the A value is to get what the parabola looks like.